Artyom Novikov. I'm about to present the tic-tac-toe game. So first let me present how it works. Play X, then computer turns, then my, and it will be either draw or I will lose. First turn it's AI. We wait a little bit and then make our turn. So then the code. So runner pi already done, and tic-tac-toe logic from me. So we have initial state, it's an empty board with 3 and 3 grid. So first we calculate whose turn is it. So here is if x count equals to O count, the turn is x because x starts in first. So if x is equal, so it's x turn. If not, it's O turn. Then actions. We finds all empty squares where the next player can move, and then result. This takes the current board that we have and a move and applies that move and returns a new board. So there we have winner function. This function looks at all rows, columns, diagonals, and if there is 3x or 3 O's in line, we have a winner. Otherwise, it's return none, so nothing. So then we have terminal. So this checks the game is over. The game over if we have winner or we have all fields are completed and full. Then we have utility function. It is the scaring function. So if x wins, we do return 1 plus 1. If it's draw, we return 0, and if it's win O, we return -1. Then we have the main function that's called minimax, and it's calculate how to do the turn. So we have minval and maxval. Minimax function it finds the best move for the current player. So if it's the AI turn, for example x, we look at every possible move. For each move, we ask what's the worst the opponent could do after this. We pick the move where the opponent worst case is the least bad and take this turn. If the opponent turn O, for example, we think the opposite. We look for the moves that gives the opponent the worst result. So we try to do the worst for the opponent. And we have function maxval. That's the function that calculates the best possible score the AI can get. So we start with -100,000. And if the score is better than the previous one, we put this score in the best result. Then we have minval. So it calculates the worst score the AI can get. So if we have current score, it goes through maxval, and if score is less than best, we give the best amount value of current score and return the best. So next I uploaded the CSV file with 18 Russian cities and 32 roads between them. It's like a map. So I imported pandas and used it to read this data and created a graph, which is used to create a structure that shows that city A connected to city B and etc. With a distance of 150 kilometers. So here is the result when we process it. So informed search, so BFS 146, 326 for DFS, A star 146, minimax 284, and alpha beta running 326. So here I just read the CSV file, and here I create a graph to analyze this data. So then here this creates a connection both direction. So if we can go to Moscow from Moscow to Tver, we can go from Tver to Moscow, and here we create the sorted list. So first it's informed search BFS. So here we starting with city and you want to reach a destination. BFS is like exploring all layers. You check all neighbors first, then all neighbors of neighbors, and then go on in the same temp. So it's like a wave that's spreading around and cover all the cities one to one. So here we use Q, first in first out, and if we got nothing, we return none. Then DFS. DFS it's depth. So we instead of it's opposite. So instead of going layer by layer, we go deep into one branch until we find the needed path before coming back. So we, like in a forest, we go straight forward and until we see the exit. We here use stack. It's first in, last out, and we push items and then pop the last one added. Here you can see. Then a star algorithm. a star uses knowledge about where the target is. It has a formula f equals g plus h, the distance we already traveled, an estimate of how far for the goal we are, and the total predicted distance. The algorithm we sort, you can see here, new distance plus heuristic function, and then explore best option first. So we list it by the score and always pick the best one. In my code, the heuristic is 0, meaning we don't have information, so it acts like we added real distance calculation for even better performance. Here it's adversarial search. It's when two players competing in between them. So one wants the longest road and one wants the shortest road. So it's minimax function. So we wants to maximize the score and wants longer, more valuable roads, and second player wants to minimize and wants the shorter, cheaper roads. So we algorithm builds a game tree of all possible moves to a certain depth. So at the bottom level we return scores, at minimal nodes we pick the smallest value, and at max nodes we pick the largest value. So then we work back at the top, and if it's like both players are playing optimally, we do that each of these players makes the best moves for themselves. So here's a function for maximizing, and here minimizing. Then it's alpha beta. So the idea is if you discover that branch definitely will not give you a better score, we don't explore it, and we also think in way when if you're looking for the best restaurant on the street, you find a 5-star place and you don't need to keep searching other restaurants. You just put your closest things here, and we will not have any other results. So alpha is the best score, the maximizer also maximizing function, and beta, best score, the minimizer can guarantee. So if beta minus or equal to alpha, we can stop and keep it here. Equal to alpha, we break. So we keep our things here.